model of the solar system with the sun being 1 millimeter in diameter. And see, that's a millimeter. Here's a ruler. This is a ruler. And you see, top is inches. That's 1 inch. And on the bottom are millimeters. So this is 37 millimeters. This is 1 millimeter from here to here. That's 1 millimeter. That's 1 centimeter. I'm sorry. It's 1 centimeter. And each one of these is a millimeter. This is an inch. So this video is about a model of the solar system with the sun being 1 millimeter. So let's so what I've done is so this is the solar system right here. You've got that pink thing, it's Jupiter. The size is not to scale. The size is not to scale. But the distance from, so that's Jupiter. Where's, oh, wait a minute. Oh, that's Jupiter. I'm sorry. That's Jupiter there. That's Saturn. Uranus, or Uranus. Neptune. And last but not least, Pluto. That's the solar system. But you might say, now where's the Earth? Okay. And the Earth and Venus, where am I here? Where's the Earth and Venus and Mercury and all that? Well, they're on this piece of paper here. Now, let's get back here. That's the sun. That's drawn to scale. That is to scale. That's about 1 millimeter in diameter. Now this is to scale. So on that scale, this is how close Mercury would be. But that's not the size that Mercury would be. The actual, on this scale, Mercury would be 1/10,000th of an inch. 1/10,000th. Of course, when I showed you what an inch was, you know, most of the world doesn't use inches and feet. Just people in the United States use inches and feet. Where did I put that roller? Oh well. Oh, there it is. You saw what it looked like. You saw what an inch was. All right. So then we have Venus. Now, of course, the actual Venus would be 3/10,000ths of an inch. It would be you would need a microscope to see if it was drawn to scale. Now, the sun, though, is to scale, and these distances aren't to scale. Here's the Earth. The Earth would be the same size as Venus, 3/10,000ths of an inch in diameter, and it would be microscopic. And that's Mars. Once again, Mars would be 1/10,000th of an inch in diameter if it was drawn to scale, and it would be microscopic if you had a microscope to see its own. So, I'm going to put that here. So, here, now our solar system is complete. The distances that the size of the planets is not to scale, but the distances from the sun, which is right there, that is to scale. So here's Jupiter. Jupiter on this scale would be four 1,000. So Jupiter is the largest. Would be 4/1,000ths of an inch. Yeah. So as I said, this piece of paper over here is not a scale. You would need a microscope or to actually see it on this scale. And here's Saturn. One. Anyway. 32/1,000ths of an inch. So the point I'm trying to make is these planets would be microscopic on this scale. That's the point I'm trying to make here. Uranus would be 13/1,000ths of an inch. Oh, you need a microscope to see it. And here we have Neptune. But over here, and Pluto, which is really, Pluto is smaller than our moon. So why is it a planet and the moon isn't? Because Pluto goes around the sun and the moon doesn't. So here's our solar system on the scale that I was. It's our solar system. And just here's some on this scale. On this scale. On this scale. Speed of light on this scale is 8/1,000ths of an inch per second. So you saw, let me get that ruler. Now, speed of light on this scale is 8/1,000ths of an inch. And let me see an inch right here. So a light year on this scale would be 4.2 miles. A light year on this scale would be 4. And the distance to the closest star, Alpha Centauri, which is actually 3 stars, would be 18, or a light year would be 4.2 miles or 7.7 kilometers. Distance to Alpha Centauri, the closest star, would be 18 miles or 29 kilometers. So I hope you have a little better idea of our solar system, the speed of light, all of that.